This is Christian Galindo with the ENME 351 lab number 3. Below are my answers to the pre-lab. For number 1, the 2000 within the delay microseconds command stands for 2000 microseconds. An unsigned variable is permitted within inside of this command. Analog write and the digital write have key differences. Analog write has PWM capabilities, so as the command implies, analog write is used to write an analog value between 0 and 255 for an Arduino Uno. This command can be used to vary brightness of an LED, drive different motor speeds, and more stuff. Digital write simply writes a high or low state to a pin. The command can be used to turn a device on or off, such as an LED. Number 3. The following pins can be used for analog write: 3, 5, 6, 9, 10, 11. And the following ones can be used for digital write: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. You can also use the analog pins on the left side of the board, A0, A1, A2, A3, A4, and A5, although it's not recommended. Number 4, analog write is on a scale of 0 to 255, which was choice B. Number 5, Arduino Uno's PWM frequency on most pins is 490 Hz. However, on pins 5 and 6, the PWM frequency can be 980 Hz. I found this information on the Arduino website. I've uploaded the blink command to my Arduino Uno. Now, let's understand the code line by line. For the first line, we've set the speed as an integer of 1000, which will be used as 1000 milliseconds within the delay function. For void setup, we have pin mode LED bulletin set as an output. Reading these comments above, we see the LED bulletin is set at pin 13, so not only will that be visible on my solderless breadboard as an LED, but also as an LED on the Arduino itself. Within the loop, we use digital write to turn the LED on and off, high and low values, and the delay of speed turns the LED on and off at a delay of 1000 milliseconds or 1 second. Here we see the LED blinking on and off every 1 second, which is also visible on the Arduino Uno. For the blink faster question on the lab, I set a variable called delay length as an integer to 500 milliseconds or half a second. Now, we can see that the LED blinks a little faster than it did in the last example. Same thing under Arduino as well. However, we want to set that variable to a number where we can't really tell that the LED is even blinking. So after playing around with it for a while, if we set the LED, or the delay, to 13 milliseconds, upload it, we will find that the LED is blinking at a really fast rate and not visible to the human eye. The fade function assigns an analog value to the brightness of the LED. Here, the fade amount variable, which is assigned as 5, increases the analog value of the brightness of the LED every 30 milliseconds. Once the brightness level of 255 is reached, the fade amount switches signs and decreases back down to 0. And once that 0 value is reached, it switches signs again and increases back up to 255, resulting in this fade behavior. If I change the duty cycle variable brightness to 20 instead of 0 in the definition as well as in the if loop, we find out that the LED does not completely turn off when reaching its negative or minimum position. Here, the LED stays on until a certain point. Although it does fade, it does not completely turn off. Here's my code for number 4. I modified the fade code, taking out all analog writes and placing in digital writes, so the LED blink 4 times, fade down, blink 4 times, fade back up. Here I modified the fade amount from 10 to 20, so now the LED fades up and fades down noticeably faster. Here I modified the fade amount to 5, therefore we see a slower fade on the LED. For problem 5, I created a stopwatch in my Arduino code. This code uses delays as well as serial prints to project a stopwatch onto the serial monitor. This stopwatch will work for up to 100 hours. In addition to the serial monitor, I hooked up the code to 2 alternating LEDs of 2 different colors. The red and green LEDs blink interchangeably every 1 second. Every resistor used within this lab is orange, orange, brown, or 330 ohms. Thank you.